Working with L systems to create rivers was done by using a turtle structure, a queue stack of turtles, and maps to create expansion and drawing operations. There are two rivers in the scene which both overlap when run together. I had trouble positioning the rivers such that they were both obvious in the terrain, especially because it takes a very long time to load the terrain with these rivers. Seen first is the linear river with two branches and a few streams going slightly away from the main body of water. The rotation with the linear river was by 10.13 degrees instead of 45. Next is the delta river with 5 branches, creating a winding effect. These rivers continue as you expand the terrain and are sloped down from the terrain in a step-like fashion. The cutting away from the terrain also slowed down the code quite a bit, causing setbacks, but overall the rivers are displayed throughout the terrain and are 15 to 20 blocks wide.
For the second milestone, I implemented texturing and animation. This involved adding UV coordinates, cosine power, and an animation flag to the interleave VBO. In the Lambert shader, I added blend-fong lighting to use the cosine power when calculating specular intensity. In order to add transparent blocks, I added a second VBO which contains the data for only those blocks, but the VBOs are filled in a single passive create. The shader uses the input animation flag to determine whether to animate the given UV, and as you can see, I made the sides of liquids flow downward. In addition to transparent blocks, I also added blocks which don't occupy an entire 1 by 1 by 1 space, like the water and lava you see here. Blocks behind these incomplete blocks will still have their faces rendered since they may be seen. Using several helper methods for positioning corners, I also allowed liquids to have their holes differently shaped based on surrounding blocks in order to ensure that these incomplete blocks connect with their neighboring ones and flow together.
To simulate swimming, I altered the game physics so that the player's velocity from gravity and movement are 2/3 of the original. When spacebar is held, the player moves upwards at a constant velocity. When a water block is entered, a blue overlay is applied to the screen. And when a lava block is entered, a red transparent overlay is applied to the screen. The physics in the lava and water blocks are identical. To implement multi-threading, I created a queue-runnable subclass, which creates a new chunk in its overrided run function. This subclass uses the lock and unlock methods of a mutex instance to prevent race conditions. The subclass is passed to a queue thread pool's global instance whenever the player moves to the boundaries of the current chunk.